Hi, welcome back. So in this new episode we're going to add support for disposing, having deterministic disposal of instances created by a container. So that will mean that when we dispose a container or a container hierarchy, basically all the instances that were created by that container as well as all the child containers will be disposed on a single pass. Of course that will be an option, so we will be able to also pick that instances are not disposed by container. So let's go here and so let's create a new test and say container own instances disposed, and we'll have basically there are two different orthogonal features that we have here. One is the ownership of the instances, and the other one is the scope for reuse of those instances, and those are different. So for the reuse, remember we had hierarchy, container, and none. Basically none is the one where we get a new instance every time. Now the fact that we get a new instance every time doesn't mean that we don't want to have that instance disposed when we dispose the container. So that's why that's an entirely different matter, who is the owner of an instance versus how we reuse those instances. So let's go and create the builder again, and because we're going to be dealing with a disposal interface, we probably should have a class disposal. Let's say it implements IFU and a disposal, and let's have it so that it has a public property that we can make assertions on. Okay, good. Builder register a new disposable, and here we were gonna say first that the reuse is none, because we'll need a test for each one. Are disposed container own instances, non-reuse instances are disposed. Okay, so reuse none, and owner, this is the API we want to have, and owner actually reused within and owned by container. How about that? Yeah, I think that's a good syntax. Probably if we say owned by, probably reuse within should be reused within. Yeah, let's rename that. That's better. So owned by the container, reused as none, and what we want to happen is container build, and let's get the disposable from there. Container dot zone, and what we want to happen is when we do container dot dispose, we want to have the foo dot is disposed set to true, because we want to have this method invoked. Okay, so let's work out the API here. So we have register reused within. In order to be able to dot after the reuse within, the first thing we need to do is make this return something. So reused within should return the registration itself. So we can call more methods on the registration, and now we need to add the owned by. So let's go here. We'll have an owner concept, so let's go and add that. And the owner is going to be an enum, and we'll have basically two types of ownership: container, that's the one we will be using now, and later on we'll add external. Okay, we don't need to do that at this point because we didn't get there yet. So public registration, actually this can be void because we are not dotting after the, sorry, let's go here. We are not dotting anymore after the owned by. We'll work out how to clean up the Fluent interface later on. So owned by owner. And just as we did for the scope and the name, we'll have a owner there, owner. Good. So now the Fluent interface is compiling. Now let's go for this. Container should have a dispose method. So let's go and implement disposal there. Let's come here and say, there we go. Let's think about what we need to happen there. First, this compiles. Let's run. Of course, it's not going to pass. Yep, it's false. And let's work out what needs to be done here. So we have a reused within none, but the owner is the container, and we want that instance to be disposed when we dispose the container. So let's go to the container. Let's close that one, and let's see where we are creating the instances for the reuse scope none here. So the first thing is we need to somehow track the instance that we have created here and basically dispose it appropriately. So in order to do that, let's create a helper method here. Let's call it tservice create instance. We will need the type of the service and type of the func. Okay, and what we will receive is the service entry, maybe, and yeah, that's all we need here. So let's make this guy actually do the invocation and create instance. And what should happen here? Var instance equal, well, we had that. And oh, we'll need the invoker here. So the invoker is the tfunc tservice. So it's a function of tfunc tservice invoker. Okay, so we have the instance. Now we need to check for the properties on this. The first thing we need to do is remember here in the test we only want to track when the owner of the instance is set to the container. So the first thing is we need to check if the entry dot owner, and we don't have, so we have the scope in the service entry but we don't have the owner. So let's go and add that to the service entry here. Let's add a new property, owner. When we clone, we should be cloning also the owner. Okay, and in the meantime I added a test feature also for the service entry, as we should always do. Container. This basically makes sure that when we clone we are actually copying all the relevant properties and so on. So we do have the owner on the service entry. So back here, now what we need to do we're missing one step here in the container builder. When we are registering, we should also specify the owner for the service entry, which should be the owner on the registration. Okay. Back in the container, if the entry owner is the container and the instance we created is an iDisposable, then we should track it. And by track it, we mean we should keep it in a list of somewhere, and then basically call dispose when we dispose the container. So let's first return an instance here, and the place where we're gonna keep it is, let's say, a private list disposables dot push instance. So let's go up here. Let's add the this could be a list or a stack or anything really. Let's make it a stack of disposals. And here we'll do while disposals count is greater than 0, we can do disposals pop dispose. Okay. Now we should be casting this to iDisposable. Okay, let's go and run the test and see if it works. Okay, pass. Now, one thing that we don't want to happen is to keep references longer than necessary. So right now we are keeping in that stack of disposables a strong reference to the component we just created. Now, because the reuse for those components is none, so basically we are handing out a new one every time. It may be that we are no longer using that object, but it will be kept around as long as the container is around, just because we are tracking that object for disposable, and that's not good. So let's make a test that forces us to not keep strong references on that. So container-owned non-reuse instances are not kept alive. So in this case, if I were to create a weak reference to my object, and then I were to set the variable to null, so I'm not using the foo anymore, and if I do a garbage collect over here, basically I should have is false for the weak reference is alive. So basically when I stop using this foo reference, because there is no reuse for that instance at the container level, it should be garbage collected, and the container should not be keeping the instance around longer than necessary. So let's see what happens. It fails, of course, because we're keeping a strong reference. So let's go and make that test pass. So rather than keeping a strong reference here, what we can do is keep a new weak reference to the instance, okay, and basically make the stack of weak references. And what we can do here is disposables.pop the weak reference, and basically check first if the target is alive. At that point we retrieve the instance and dispose it. So let's do disposable equals iDisposable of the weak reference target, and let's check if the weak reference is alive, then the disposable dot dispose. Okay, so back to the unit test. Let's see if that actually fixed the problem. Yep, it did. So now let's move on to the other scenario, which is that the container scoped. Container owned and container reused instances are disposed. So now we want to test for the reuse on the container. So we change the reuse within and basically run the same test as before. Let's see if that works. No, it doesn't, of course. And let's go back to the container and see why. So now we have here another place where we are newing up an instance, and we already have this handy method there for creating an instance and tracking it. So we can basically just get rid of that and say create instance of the service Funq, pass the container entry and the invoker. And because we are reusing the same behavior we had implemented here for the creating of the instance, this should now work. Very good. Now we should do the same, but for the hierarchy. Container owned and hierarchy reused instances are disposed. Fail. Back to the container, and we are also creating the instance here, so we should also get rid of that and basically call create instance here too. Test, pass. So now let's go to what happens when we dispose hierarchy. So the first thing is I'm interested in knowing what happens when I dispose a child container and the reuse scope was container, and we had the registration on the parent. So child container instance is disposed parent. Child container instance with parent registration is disposed. So what I want to test here, I just want to make sure that the current behavior is the proper one, is I have the builder. Basically I go and register a, sorry about that, let's go and copy most of this from here. What I want to make sure is that when I get a build for the parent, then I get a child container. When I resolve an instance of the child container, and I dispose the child container, the instance is disposed. Okay, pass. We're good. So so that's good. Let's work on the hierarchy now. So child container instance with parent registration is disposed. No, you know what I'm thinking? This is actually incorrect, because the reuse scope is within hierarchy, right? So this instance should have been created on the parent container, right? Because the reuse is within the hierarchy. So instances, When the reuse is hierarchy, they should be created at the place where the registration is happening, correct? I think that's more sensible. So when I dispose the child container here, the instance should not be disposed. That's the thing which was kind of bothering me on the current code in the container. So this should actually fail, right? Should pass, but it fails. So what I mean is I'm registering foo on a parent container, correct? Then I am creating a child container. The reuse scope for instances of those of that registration is throughout the hierarchy. So that means the instances are created on the parent and then reused throughout all the child containers. And so when we dispose the child container, that instance should not go away, because otherwise it will not be usable by the other containers at the same level, the same other container siblings or descendants. So let's go back to the container here and see why that's going on. What's going on here? And the first thing is, remember when we go to get entry and retrieve the service entry, this basically goes and walks up the container hierarchy to retrieve the instance, the registration for the service. So it may be that in the case of hierarchy, we end up with an entry whose container is not ourselves, but a parent. And by invoking create instance here, basically we are tracking the disposal of this instance locally, rather than leaving that up to the parent container. So it looks like what we should be doing here is rather than creating the instance ourselves, letting the parent container where this entry has been registered resolve that instance. So how can we do that? And I think the easiest way to do that would be to just rely on the same resolved implementation that we are living in at this point. So let's say that if the instance is null, then here we can two things can happen, right? It can either be that the entry is myself or not. If it is not this, then I can resolve the instance from the parent. But in that case, when the parent creates the instance, it will assign that to the entry, so we can basically return from here. So we can move this up and say that if the entry container is not ourselves, then we can do a entry container dot resolve implementation of the service Funq, and basically pass the responsibility to do all the work to that guy. Right? Else, if the instance is null, then we create it. Okay? So, if the entry that we got from the lookup is for a container that is not ourselves, then we will let that container do the resolve of the implementation. So that will come back here. It will get back here, get into the entry scope. It will be hierarchy, but the next time when we call this and we come back, the container will be equal to this. So we will enter here and we will get an instance created and tracked for disposal, and we will return the instance. Okay? Otherwise, we'll just create it here. Yeah, I think that's all that needs to happen. So let's see if that actually made the test pass. Yeah, cool. So now we are tracking disposal of instances on the child container, and on the parent container. Now what we need to add is a new test, which is that disposing parent container, disposes child container, and instances. So this will be mixed. So now this is the exact opposite of the previous one. Okay, so basically what we want to do is essentially very much the same as before, but now the reuse scope can be anything really, because we already tested for container, hierarchy, and none. So let's do none. And the owner should be the container. And what we want to happen is that when we resolve on a child container, the registration from the parent will kick in and we'll get an instance. And what we want to happen is that disposing the parent disposes the instance. Okay? This pass. Wow. Now this should be true. That was easy to make pass, right? Okay. Fails because the child, the instance was not disposed. So now let's go and add that behavior. Basically what we need to do when we dispose is track our, basically go and dispose all the child containers, right? We don't have a list of child containers here. Good, so this is a good point and a good moment to add that behavior. So we are not tracking the child containers, so that means that we should probably be doing that. And let's do the same as we did before. Let's add a stack of container and it's okay for us to keep strong reference to child containers because they form a hierarchy. And so let's push that one here, child container, add, push, child. And finally here, let's do also the while, child, count, child, dispose. Okay, and the test passes. So good, we are disposing container hierarchies, and what we need to add now is the ability to specify that the container should not dispose things. So the other owner should be external, and let's add a test that disposing container does not dispose external instances. So we're not going to have parent child, so something like this would be enough. So reuse doesn't matter which one. The owner should be external, and now this should be false. This should probably work because we are already checking that the owner is container. Yep, it works. So if we go back here, then remember when we added the behavior here, we basically added the if the owner is the container. So let's run all the tests once more, and with that we'll finish the current episode. And the next one will be dedicated to polishing the Fluent interface, which is at this point kind of like a mess. It's just a public class with some things that return the registration, others are void, and we have all those properties popping up on the tests. So right now if you look at the register and what we get back, it's not very fluent, right? So there's a little bit of everything. So on the next one we'll work on how to make up a Fluent API. Thanks and stay tuned.